Have you ever just felt totally overwhelmed by a big decision? Well, today, we're going to dive into something called the greedy algorithm. It's this really powerful problem-solving technique that's all about making the best choice you can right now. And the funny thing is, you probably use it every single day without even realizing it.
I mean, seriously, think about it. When you're staring down a huge, complex problem with a million different options, how do you even begin to find the best path forward? It's a question that can challenge even the most powerful computers out there.
The greedy approach has this beautifully simple answer. You just make the best possible choice you can see at this very moment, and then you do it again. In this Explain It, we're going to break down exactly how that works. And for all of you who want to go even deeper, don't worry, we've got full technical notes and all the code examples we talk about waiting for you in the description below. Okay, so what does it actually mean to be greedy when we're talking about algorithms? Let's define it.
Now, I know that sounds super technical, but the idea is actually pretty simple. Locally optimal just means the best choice available to you right now, without getting bogged down thinking about the future. The algorithm just greedily snatches up whatever looks best in the moment, hoping that a whole series of these best right now choices will eventually lead to the best overall solution.
Let's make this real. We're going to look at a real-world example, something pretty much all of us do instinctively. Okay, imagine you need to give someone, say, 68 cents in change. How do you do it using the fewest possible coins? Your brain solves this almost instantly, right? And guess what? It's using a greedy algorithm to do it.
You'd naturally start with the biggest coin you can, a quarter. 2 of those gets you to 50 cents. Okay, what's next? A dime. Now we're at 60. Then a nickel gets us to 65. And finally, 3 pennies to hit 68 exactly. See? At each step, you made the locally optimal choice. You took the biggest coin possible. And for most standard currencies, this strategy works perfectly every time.
All right, so that one was pretty straightforward. Now let's take that same logic and apply it to something a little more complex. Maybe a high-stakes business problem like scheduling jobs to maximize your profit.
So here's the scenario. We've got 5 different jobs we can do. Each one takes just 1 unit of time to complete, but each one has a different deadline it has to be finished by, and of course, a different profit. Our goal is to figure out the sequence of jobs that's going to make us the most money.
So what's the greedy choice in this situation? It's pretty obvious. You go for the money. The best choice right now is always going to be the job that pays the most. So our strategy is simple. First, we sort all the jobs by profit, from highest to lowest. Then we try to schedule them one by one.
And there we go. We've sorted our list. Job A is clearly the big winner, followed by C, then D, and so on down the line. Now we have a clear, greedy path to follow.
So let's imagine we've got 3 available time slots to get our work done. We're going to start, of course, with our highest profit job, which is job A, and figure out where we can put it. Okay, job A has a deadline of 2 and a juicy profit of 100. Now here's a really key part of this strategy. To keep our options open for other jobs, we schedule it in the latest possible time slot it can fit in. Since its deadline is 2, that means slot 2. That's our first greedy move.
Next on our list is job C, with a profit of 27 and a deadline of 2. Well, slot 2 is already taken by our big moneymaker, so we place job C in the latest available slot before its deadline, which leaves us with slot 1.
Okay, now for the really crucial part. We look at the next job, Deed. It has a profit of 25, but its deadline is 1. Slot 1 is already taken, so we have to skip it. We just can't do it. Same thing for job B. Finally, we get to job E. It has a deadline of 3, and hey, slot 3 is free, so we pop it in there. And there you have it. Our final, most profitable schedule is C, A, and E. Okay, for our last example, let's talk about a technology that is just absolutely fundamental to how our digital world functions: data compression. Specifically, a clever technique called Huffman coding. This is literally how files like zip files get so much smaller without losing a single bit of information. The whole idea is to give very short binary codes to characters that show up all the time, and then give longer codes to characters that are really rare. And how it does this is a brilliant, greedy strategy. Now, the strategy here is a little counterintuitive, which is what makes it so cool. To build the most efficient code possible, you greedily and repeatedly combine the 2 least frequent characters. By doing this over and over, you're actually pushing the rarest characters to the very bottom of the code tree, which automatically gives them the longest codes. Let's see how this gets started. So here are our character frequencies in some text. The greedy choice is to find the 2 with the lowest counts.
A quick scan shows us that's E with 9 and F with 5. So we merge them together into a new node that has a combined frequency of 14.
And now we just repeat the process. Our new E plus F node has that frequency of 14. Looking at our updated list, the two with the lowest frequencies are now C at 12 and B at 13. So you guessed it, our next greedy move is to combine them.
And this just keeps on going. You just greedily merge the two lowest frequency nodes over and over and over again. By always picking the rarest characters to combine, you naturally push them further and further down the final tree. This automatically gives them longer codes, and the most frequent characters, like our A, end up near the top, which means they get the shortest codes. It's an incredibly elegant solution.
So after seeing all these different examples, what's the big takeaway here? When should we actually reach for this greedy approach?
Well, the huge advantage is that these algorithms are often incredibly fast and relatively simple to implement. But here's the catch, and it's a big one. They do not work for every problem. They only work perfectly on problems that have what's called the greedy choice property. That's where making the best local choice is guaranteed to lead to the best global solution. For other problems, a choice that looks great right now might lead you down a dead end later. It's a powerful shortcut for sure, but it's not a silver bullet.
And that brings us right to the end. The greedy algorithm, as you can see, is more than just computer code. It's a mental model for making decisions. So I'll leave you with this to think about. Where else in your life do you use a greedy approach to make your choices? The next time you face a tough decision, ask yourself, what's the best possible choice for right now? You might be surprised where that thinking takes you.